The other day we were talking about just counting atoms in molecules and then counting atoms in a chemical reaction, looking at the reactants and the products. Okay, and what we're going to be doing today is balancing these chemical reactions. And the reason we need to balance them is because, like I said, they actually represent something. They represent the atoms and molecules involved in the chemical reaction. Okay, they actually represent physical things. Okay, and when we have a reaction, our reactants are on the left-hand side of the arrow, and then the products are on the right-hand side. So we start with reactants and we make products. And it's just a rearrangement of reactants to make products. So you're rearranging the atoms in the reactants to make products. Okay, whatever you start with has to be equal to whatever you end with. Okay, so we have to make sure we show it all the atoms are balanced. You have the same number of atoms of carbon on both sides, same number of hydrogens, same number of oxygens. Okay, so it has to be balanced. All right, and there's a reason for that. Other than just the conservation of mass, because later on we actually use these reactions, we can actually figure out quantitatively how much reactants we need to make a certain amount of products, or how much products we will make if we have a certain amount of reactants. Okay, now we can do that pretty easily, and if you do take chemistry with me in the future, or with anyone in the future, you'll learn how that's done, but we're not going to do that in this class. Okay. So, again, a rearrangement of atoms, breaking or making of bonds. So here's just another example, H2 plus O2 yields H2O. So you see that we can't just have H2 and O2 yielding H2O, because that would not have an even number of hydrogens and oxygens. We actually need 2 water molecules, and we need 2 hydrogen molecules. Okay, so basically we have to balance the reactions. We have to balance the reactions and products. Okay, and that's, again, because of the law of conservation of mass. Mass cannot be created or destroyed, right? And the only way to balance these reactions is to add coefficients. Okay, subscripts do not change because subscripts actually change the chemical makeup or the chemical formula of the reactants or products. Okay, and we're not changing those things because we're looking at a specific type of reaction. Instead, we're just changing the coefficients. Okay, so I'm going to go through, I think, 6 examples for you guys, and then you have the job of doing 15 for classwork/homework today, and 15 for classwork/homework tomorrow. Tomorrow we won't have in-person meeting class. However, if you do need help, there's going to be office hours tomorrow, as there is every Wednesday. But if you do need help, please send me an email or some other message through Google Classrooms that you need help, and we'll arrange a time to work through some of the problems. But in reality, balancing chemical reactions is a very simple process, but it can be hard depending on what the reaction is. Okay, but really the rules are really simple. Okay, the rules are really simple. Oh, and I forgot that I have that in the slide. Basically, these are the steps. First, you count the number of each atom in products and reactants. You compare them. Then you place coefficients in front of the molecules or atoms. Then you recount. And then you repeat that until they're equal on both sides. There are a lot of little tricks, a lot of little tips. As you practice more and more, you'll notice some things. I'm going to point out a couple today as I go through some examples. But really, it's just practice. Really, it's just, kind of like a little bit of a brain teaser. It's kind of like a little puzzle, right? So we're going to start really simple, like really simple. So this is a very simple problem. So what I like to do when I start these problems is right down the center, I draw a little column. Okay, because in the center column, I write my my elements that are there. So I have aluminum and I have nitrogen. Okay, so we do our initial count. Our initial count, here we have 1 aluminum, and here we have 2 nitrogen. Here we have 1 aluminum, and here we have 1 nitrogen. So ultimately our goal is that both sides, the left and right hand side, so the reactants and products, both of them are equal. Okay, and the only way to make them equal is to change the coefficients. Okay, so you see here we have 2 nitrogen and only 1, so we actually need 2 nitrogen on the right hand side here. Now the only thing we can do is put numbers in front of these molecules. Okay, we can only put numbers in front of the molecules. We can't put subscripts, we can't put something in the middle of a molecule, we can only put them at the beginning of a molecule. Okay, so here we need 2 nitrogen, so we put 2 here. And then every time we put a coefficient, we want to recount. So now we have 2 aluminum and 2 nitrogen. So now you see one of the problems that we usually have is when we add a coefficient, sometimes it will fix one, but it'll mess up the other, right? And that's okay, because we just have to keep moving forward until we find the right answer. So here, we need 2 more aluminum, so we put a 2 here. And again, every time I put a coefficient, I recount. Now I have 2. So now you'll see I have 2, 2, 2, 2. So everything is even. So now this is a balanced reaction. Okay. You also notice that I didn't put a number in front of N2 here. There's no number in front of N2. That's okay. It's just an invisible 1. It's an invisible 1. If it makes you feel better, you can write a 1. But it's fine to just leave it blank. So this overall balanced chemical reaction would be 2Al plus N2 yields 2ALN. No, you don't have to put the 1. I actually prefer it if you don't put the 1. I prefer if you don't put the 1. Okay, but if there's no number there, it's a 1. Okay, I prefer you don't put the 1 because in general we don't write it in chemistry. We don't write the 1. Okay, so that's a pretty simple one. Okay, I have another simple one here. So why don't you take like a minute, if you have a separate sheet of paper around, why don't you try and do this one on your own here. So again, I like to put my little column in the middle here. Makes it really simple, easy. We just have Fe and O. We do our initial count. As you get better at these, you kind of do it in your head, but for now, just do it this way. So Fe you have 1, O you have 2, Fe you have 3, O you have 4. Okay. So one of the little tips is to balance metals plus cations first. So if you have whatever's in the front, it's usually you want to balance those first, and balance oxygen and hydrogen last. That typically helps. Now these are not rules. There's no real rules to this other than just put a coefficient and recount. Okay, these are not rules, but I generally like to balance metals or cations first, and then wait and do my oxygens and hydrogens last. Okay, so really I like to work from the left side of the formula first, so anything on the left hand side, because cations usually come on the left hand side. Okay, so here, and this one happens to work out pretty easily, but whatever. So here we have iron needs 3 here. Okay, so we need 3 irons here, so we're going to put a 3. So another a little trick and tip, and one of the things a lot of people make mistakes on is that they try to look at this number and then add whatever, like, so you put a 3 here. Oh, well, now I have 2 more, so 1 plus 2 is 3. No. Every time you put a new new coefficient, just do the recount. Just ignore the number you had before. Don't even think about this number. Don't even think about it. Just think about, okay, when I put a coefficient here, what is the new number? Don't try and add it to what you had before. Okay, do the whole recount. Do the whole recount. Okay, that's one of the things that messes a lot of people up, is that they try to, what happens is I get a lot of people writing a 2 here, and then this 2 plus 1 is 3. No, that's not how it works. It's 3 times Fe gives you 3. Okay. Then here we have 2 oxygens. We need 4. So multiply by 2. Again, now that we put a coefficient here and we change the number of oxygens, now just cross that out. Don't even think about that number. Don't even think about that number. It's gone. We have a coefficient in front now. So use that coefficient and do your counting. Okay, don't even think about the number that was there before. Okay, so 2 times 2 is 4. Don't try and add the old number. Once you put a coefficient, it's changing that element. Don't think about what it was before. Recount. Do the whole recount. Okay. Trust me, I've been doing this a long time and seen a lot of mistakes, and that's probably one of the hardest things that people often come by. They start trying to add things together. Doesn't work. Doesn't help. Okay. Okay, so let's look at a trickier one here. So they do get tricky. Okay, so here, this one, we have CH and O. So again, here, CH and O. Okay, so again, I like to balance oxygens and hydrogens last. And sometimes though, it's gonna take more than one step. So everything so far, we just had to change number once, and it's pretty good, pretty easy. But sometimes it gets a little bit more challenging and more difficult. Okay, one of the things that, if you notice, so one of the things I always notice is once we have oxygen here, it has 2, and then we have a 2 here and 1 here. This is going to make it difficult to balance. Okay, we have two different oxygens on the product side, and one is odd, and this one's even. So it's going to make it tricky. So first of all, as I said, I like to balance everything but oxygen, hydrogen first. So let's do. No one invented this. It is what it is. People have figured it out. Okay. So first thing, let's balance the carbons. So carbons, there's 6, or actually we have to do our count first, right? We have to do our count. 6, and this says 2. This says 1. This says 2, and this is 2 plus 1 is 3. So they do add together. The oxygens add together. Okay. Okay, so let's balance our carbons first. So we have 6 on this side, so we need 6 here, so put a 6. Okay, and then recount. Now we're going to mess up our carbons, now we're going to mess up our oxygens. So don't even think about these numbers. Do a recount. Don't even think about those numbers that were there before. Recount it all together. So now we have 6 carbons, and then we have 6 times 2 is 12. But don't forget about these two, this one here, so it's 13. Okay. Okay, now next we want to balance our hydrogens and our oxygens. Now, because our oxygens here there's 2 of them, right? No matter what number we multiply this by, we can't get 13. We can't get 13. Yeah, this is gonna really mess us up. Okay, that's okay. We're gonna power through this. We're gonna figure this out. This is again where a lot of people get confused. All right. So really, there's a whole bunch of different ways we can go about this. Really, like 2 different ways, I guess. I personally, I like to think, okay, well, I know that I can't get my 13 here, but let's try to at least balance the hydrogens, and then we'll figure out the oxygens from there. Okay, so let's do the hydrogens. So hydrogens, we have 6 on the left-hand side, we need 6 on the right. So that means we need 3 here. And again, anytime we change, so now we're changing the hydrogens to oxygen, so automatically just cross those out, don't even think about them anymore, and do our recount. So 6 times 2 is 12, plus 3 is 15. Okay, and then 3 times 2 is 6. Okay. Oh, so now again, there's no number I can put here, no whole number I can put here to make this O2 have 15. Okay, so as soon as I see that, the way I do it is I just multiply everything by 2. However, if you watch some other YouTube videos or some other people, the way they do this is what they'll do is they know they need 15 oxygens here. Well, if you need 15 oxygens, that means you need 15 over 2 O2s. Because 15 over 2 times 2 equals 15. Those cancel and you get 15. Okay? But again, I don't think of it that way. I think of it as just like, okay, as soon as I see that this number is off, I can't make it, I just multiply everything by 2, because the next step you're going to do here is multiply everything by 2, because you can't have a fraction in a balanced chemical reaction. Okay, you can't have a fraction there. Okay, so again, you could do the 15 over 2 and then multiply everything by 2, and you'll get the 2C6H6 plus 15O2 12CO2 plus 6H2O. Okay, and that will be balanced if you do this and multiply everything by 2. However, the way I do it, let me show you the way I do it. And I'll take my way a little bit slower. Again, I don't do 15 over 2. As soon as I see that I can't get that, what I do is I multiply everything by 2. So I make this a 2. Okay. I leave this one blank. I leave this one blank for now. I leave this one blank. I just leave it as a 1 for now. I just leave it there. And then make that 12. And then make this 6. Okay. And then again, when I change my coefficients, I got to do a recount. So this becomes 12. This becomes 12. Oxygen staying the same. I didn't change this because that's the one that's screwed up. So I'm just leaving it there for now. Okay. And then now I have 12 carbons. And I have 12 hydrogens. And then I have 24 plus 6 is 30 oxygens. Okay, so now I have my carbons and hydrogens are good, but I got to find my oxygens. I got to make my oxygens 13. So what number times 2 gives me 30? Well, I ignore this. I say 15. 15. I get 30. And there's my balanced chemical reaction. Again, essentially all I was doing was changing coefficients. I'm changing coefficients until the number of elements on both sides are equal. That's it. That's it. All the other stuff is just tricks, tips, hints. The more you practice it, the better you get at it. It's like it's kind of like Sudoku. It's kind of like, you know, any little game puzzle you play, you know, where you're thinking logically. That's all it is. You have some rules, and you have to fit everything into those rules. And the rules for this are really simple. Change the coefficients, count the number of atoms. Okay. I'm going to show you one more trick. This one makes a lot more sense. That one's hard. That one's a little bit confusing. Now there's these types of problems where you're going to have these what we call polyatomic ions. Okay. What you'll see here is you'll see sometimes you'll have these groups of atoms together. So NO3 here and NO3 here, it stays together on both sides. Okay, they're staying together. We call these polyatomic ions. Poly means many. So many atoms that are ions. And ions are charged particles, right? So charged particles. So polyatomic ions are groups of atoms or many atoms that have a charge. All right. So these stick together. If they stick together from both sides, what we can do is we can, when we count them, so when we count our atoms here, oops. So when we do our counting, we can group them together. So we can have PB, then we can have NO3. So we don't count them separate, we count them together. And then H and Cl. And it makes it a lot simpler, So here we have one PB, we have two NO3s, we have one H and one Cl. Here on this side we have one PB, we have one NO3, one H, and two Cl. Okay. So now we're just trying to balance them again. So we need two NO3s on the right hand side, so let's put a 2 here. And again, now that we put a 2 there, we got to recount, so it makes 2 and 2. And then we need now 2 H's and 2 Cl's, so we put a 2 here. That becomes 2 and 2. And now look, it's all balanced. Super simple. So we didn't have to count all the oxygens, we didn't have to count all the nitrogens. We counted them as nitrate, NO3. Okay, so let's look at another one like this. There's actually 2 polyatomic ions in this one. So let me point them out and whoops. Let me point them out and then I'll give you a minute to try and balance it. So here we have Ba, we have Cl, and then this is NH4 is 1 and CO3 is 1. So we can actually group NH4 together and CO3 because you'll see that CO3 stays together here and here, and NH4 stays together here and here. Okay, so try to balance that. Take a second, try to see if you can balance that real quick. Here, let's do our initial count. So we have 1 barium, 2 chlorines, we have 2 NH4s, and 1 CO3. Again, that makes it so much easier, right? We don't have to count each individual atom. We can just count the polyatomic ions. Okay. On the other side, we have 1 barium, 1 chlorine, 1 of those, and 1 of those. So 1 of each. 1 of each. All right. So here we need 2 more Cl's and 2 more NH4s. So we put a 2 here. And then we get 2 and 2. Super simple. Okay. Okay. Let's try one more. And I'll give you a few minutes to try this one on your own. Oh, you know what? We're going to do this one together too. This is a tricky one. So again, sometimes these get really hard. This one is very tricky and very hard. Okay, So this one, we can't group together the NH4, the C. We can't group together anything because it's not the same on both sides. So we have to count an individual. Oh, whoops, hit the wrong. We have to group individual atoms here. So here we go. Let's do it. We have N, we have H, we have Cr, and we have O. Okay, and this one's going to be tricky. Or maybe not. Who knows? Here we have two N's. We have 8 H's. We have 2 chromiums, and we have 7 oxygens. On the other side, we have 2 nitrogens. We have 2 hydrogens. We have 2 chromiums. And we have 3 plus 1 is 4 oxygens. Oh, actually, I think this one's going to be really simple. Yep, it's going to be really, really simple. So don't get too scared of it. So we have to balance. So we already have the chromiums balanced. We have the nitrogens balanced. So we don't need to balance them, but we have to balance the hydrogens and oxygens. So since hydrogen's all by its lonesome over here, I'll do that one first and then see how it affects the oxygen and see what we can do. So here, hydrogens, we have 8 on this side, so we need 8 on this side. So in order to get 8, we have to put 4 here. Oh, that's going to make it super simple. This is actually a really easy one. 8, and then 4 oxygens plus 3 is 7. Oh, look at that. It's balanced. Oh, so easy. I meant to pick a harder one. I just thought that one looked hard. Okay, so that's it. That's it for balancing. Your job is to do those 15 problems that I assigned. I suggest you write them out